So this is the video for 3.3/3.4 notes. They're kind of just pushed together. So first thing we're going to look at is changing bases using common logarithms. So typically our common log is log base 10. You wouldn't be able to put this into the calculator. Anytime you use that log button in the calculator, it's always implied that it's a log base 10. And anytime we see log written without a base, again, it's implied that it's log base 10. So we want to change this to something that we can put in our calculator. So the change of base formula for logs, we just write log, the big one goes on top, so log of 25 over log of 4. Now this is both something that we can put in the calculator. We can put log of 25, which is 1.39794, and then we can do log of 4. So remember, this is implied that it's log base 10. So log of 4 would be 0.6020599. And then we just divide the two of these. So 1.39794 divided by 0.6020599 is 2.3219. I don't know how many decimal places WebAssign asks you to leave it in, but we can just leave it with 4 decimal places here. When doing this part, you just want to make sure that you write as many decimal places as you can, because remember, the more decimal places you write down and keep in your formula, the more exact your answer is going to be. For the second one, we do the same thing. So we're going to do log of 12 over log of 2. Remember, the bigger number always goes on top. So I always just think about it as if we do it, put a line right through it. The 12 is on top, the 2 is on the bottom. So I'm going to do log of 2 first in the calculator. So this is 0.3010299, and then log of 12 is 1.0791812, and then just divide the two of these. And this is 3.5849. So guys, remember, it's always good practice to do these in your calculator yourself, also for WebAssign, but especially when we do it together in the video. That way you know you're doing it right. That way when you get to WebAssign, you know you're putting the answers in the calculator right and getting the correct answer. Next, we have the change of base using natural logs. So remember, natural logs are ln's. So we can change our bases the same way here, but using natural logs. So instead of here and the ones above where we had base 10, we have log base e now, but the 25 still goes on top. So log base e of 25 over log base e of 4. Remember, log base e is our natural log, so that is ln of 25 over ln of 4. So we just changed our log base e to ln. So now we can put this into our calculator. ln of 25 would be 3.218875, and then the ln of 4 is 1.38629. 3.218875 divided by 1.38629, and that is 2.3 0.219. So if we look up here, we got the same exact answer as we did before. So changing our bases using natural logarithms, even though we get different decimals here than we did here, we end up getting the same answer. So let's do it for our second one. So again, we have log base e, the 12 goes on top, so the bigger number is on top, then log base e of 2. So log base e we change to ln, so ln of 12 over ln of 2. So ln of 2 is 0.693147, and then ln of 12 is 2.484906. Then we divide the two of those. So we get 3.5849. And again, it's the same exact thing we got up there. So changing bases using common logs and natural logs give us the same result. Next, we have our properties of logarithms. So first property is our product property. Anytime we have the log of two numbers that are being multiplied, we can split up these two numbers here with addition. So we split it up, we take the log of our first number plus the log of our second number. The same exact thing works for natural logarithms. So anytime we have two numbers being multiplied in here, we can split them up and take the ln of one number plus the ln of the second number. Next, we have the quotient property. Anytime we are dividing two things in our log, we can take the log of one thing minus the log of what's on the bottom. So what comes on top always has to be first, and what's on bottom always comes behind the subtraction sign. And then lastly, we have the product property. Anytime we have the log of a number raised to an exponent, we can take this exponent and move it out front of our log. And these logs properties work both ways. So anytime we have a log of some number minus a log of another, we can condense it into one log by dividing. Anytime we have the log of one number plus the log of another number, we can condense it by multiplying two numbers. So example 3 says write each logarithm in terms of ln of 2 and ln of 3. So first thing we need to do is take a look at 6. How can we change the number 6 to look like the number 2 and the number 3? We know 6 is 2 times 3. So this is the ln of 2 times 3. Right? This is the same thing as saying the ln of 6. We just broke up our 6 in 2 times 3. Now we can expand this log. Going back to our properties, we see that we are multiplying these two numbers together. It's actually the natural log one, so we're multiplying these two numbers together. So this is the same thing as saying ln of 2 plus ln of 3. So anytime we are multiplying two things in our parentheses here, we break it up. And when we break it up, we need to give each thing a log and put addition. So multiplication goes with addition, division goes with subtraction. Next, we have ln of 2 over 27. So we need this 27 to look like 2 and 3. 2 or 3. So we know 27 is 3 cubed. So this is ln of 2 over 3 cubed. So we just changed our 27 to look like a 3. Now we see we're dividing here. So we have 2 divided by 3 cubed. So we can break this up into ln of 2 minus, since we're dividing, ln of 3 cubed. And then the last thing we can do here is our power property. We can take this 3 and bring it out front. So we have ln of 2 minus 3 ln of 3. So these rules here are super important, this whole box, because this is pretty much what the whole section is about, just using these properties. All right, in example 5, we're expanding logarithmic equations. So again, we're using those properties and just expanding what we have. So here we have 5 times x cubed times y. So everything that we're multiplying inside of our log here, we're going to split it up with addition. And when we break it up, we have to give each term a log. So we have log base 4. Since it's log base 4, we're going to keep that log base 4 for everything. So log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. And then the last thing we can do is take this exponent, move it out front. So this is log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So all we did was expand our logarithm with our properties. Next, we're going to look at b. So we're going to take it one step at a time. First, we have this top square root of 3x minus 5 divided by 7. We know that we can split up division with subtraction. So this is ln of the square root of 3x minus 5 minus, because it's division, so we're using subtraction, and anytime we break it apart, we have to give it its own ln. So ln of 7. Next thing we can do is we see that what's in here, this 3x minus 5, this square root is the same thing as saying raised to the power of 1/2. So anytime we have a power, we want to move it to the front. So we're getting rid of that square root with that same thing, because the square root is the same thing as 1/2. So we want to take that exponent and move it out front. So we have 1/2 ln of 3x minus 5 minus ln of 7. Anytime that you have something in parentheses here like this with addition and subtraction inside of it, you can't break it up. So just think about it as it's being hugged. You can't break up the hug. So we can only break up multiplication and division. Here we have multiplication, but we have the subtraction in it, so we can't break up anything in here. So it has to stay in the parentheses, and these parentheses are important because we know that the ln is talking about everything in here. So we got to keep those parentheses there, and we can't break up anything else. So this is our expansion here. So let's take a look at number 6. Now we are condensing. So we need to use the properties of logarithms to condense each expression. So looking at A, anytime we have something multiplied out front, we want to bring it to the top. So we're going to bring these 1/2 to the top and the 3 to the top. And then we have addition here. So we know addition goes with multiplication. First thing I'm going to do is just bring the exponents to the top. I'm just going to do one step at a time. So we have log base 10 of x to the 1/2 power, which we could put a square root, same thing as saying to the 1/2 power, plus log base 10 of x plus 1 cubed. Now that we have the same log base 10, we can condense it even more. Since this is addition, we're going to condense it with multiplication. So when we condense it, we get rid of our logs. Our goal when condensing is to just have one log here. So we have log base 10 of x to the 1/2 times x plus 1 cubed. This is our answer here. For B, again, we're condensing. We want to take our number out front, bring it to the top so it becomes our exponent. We see we are subtracting, so that means we need to divide. So we have ln of x plus 2. I'm just going to move the number to the top first. So x plus 2 squared minus ln of x. Now I'm going to take care of that subtraction and change it to division. When I condense it, I only want one log or ln. So I have ln of x plus 2 squared and then divided by x. So that subtraction, when we condense it, we get rid of this log and change it to division. Next, for C, I'm going to work from the inside first, and then I'll deal with this 1/3 outside because I can't bring it to the top here because it's 1/3 being multiplied to 2 of our logs. So I can't bring it to the top yet. So I'm just going to deal with what's on the inside. I'm going to get this to be 1 log, and then maybe I can bring that 1/3 to the top. So here we are adding, so this means we need to condense it and multiply. So this is 1/3 log base 2 of x. We said we're multiplying, so x times x minus 4. And then since the log base 2 is talking about the x and the x minus 4, I'm just going to put parentheses around here just so we know that all of this in here is being affected by that log base 2. We can actually distribute this x in here. So we have log base 2 of x squared minus 4. And again, we need these parentheses here because we need to know that this log base 2 is not only talking about this x squared, but also the minus 4. So now that we did everything inside, we can take this number being multiplied out front and move it to the top. So we have log base 2 of x squared minus 4. Again, we keep those parentheses, and then we just put our 1/3 up here. Now I don't know how WebAssign is going to make you write the answer. It could make you leave it like this, or it could ask you to change the square root or the fraction in your exponent to a square root. So this would be log base 2 and then the cubed root of x squared minus 4. So this is the same thing as this. I would accept either answer, but I don't know how WebAssign makes you write it. So just know that these two are the same thing. Okay, so next we can take a look at this box here. Example 1, solving simple exponential and logarithmic equations. We have examples, so the first 4 are examples of our one-to-one properties. So these we all went through in the last section, A, B, C, and D. The next 4 are just examples of our inverse property. So anytime we have e raised to the x, we want to take the ln of both sides because the ln of e just cancels out. We can take this x, move it to the front, so then we just get x is equal to ln of 7, and this we can put in our calculator. So anytime we see e raised to the x, we can just take the ln of both sides and solve it that way. Next we have ln of x. Anytime we see the ln of x, we take e as our base, and what we do on one side of the equation we have to do on the other. So it's e raised to the ln of x is equal to e raised to the negative third power. And then the equation rewritten would look like this. E raised to the ln power cancels out. So that e and the ln are inverses of each other. They cancel. So then we're just left with x is equal to e raised to the negative third power. And then anytime we see log base 10 of x, we can take the inverse, which is 10. So we take 10 as our base on each side of the equation. 10 raised to the power of log 10 cancels out, so we're just left with x is equal to 10 to the power of negative 1. And then that works for any base that we have for our log, so we would take 3 here. So whatever our base is, we take that as our base here. So 3 raised to the power of log base 3, x is equal to 3 to the power of 4. So 3 to the power of log base 3 cancels out, so then we'd just be left with x is equal to 3 to the power of 4. So this is a good chart here because it helps you see any time you have an equation that looks like this. This tells you exactly what to do. Anytime you see the equation with ln of x, this tells you exactly what to do. Anytime you have a log of some base, it tells you exactly what to do. So this is a good chart to have next to you and use while doing your homework. So strategies for solving exponential and logarithmic equations. First thing we want to do is write the original equation in a form that allows us to use the one-to-one properties of exponential and logarithmic functions. So first thing we want to do is see if we can use one of these one-to-one properties. So what we did in 3.2. If that doesn't work, then we can rewrite an exponential equation in logarithmic form and apply the inverse property of logarithmic functions. If that doesn't work, then we would rewrite a logarithmic equation in exponential forms and apply the inverse property of exponential functions. So this is just strategies, which pretty much just tells you to follow these steps here. So example 2, looking at A, we see e raised to the power of x is equal to 72. This looks like step E here. When we see e raised to the power of x, we know we have to take the ln of both sides. So we have ln e to the power of x is equal to ln of 72. Remember, what we do on one side of the equation, we have to do on the other to keep it balanced. We take our x, move it out front, so x times ln of e is equal to ln of 72. ln of e is 1, so they cancel out. So x is equal to ln of 72. ln of 72 we can just put in our calculator. So x is equal to 4.2767. For b, we have 3 times 2 raised to the power of x is equal to 42. Going back to our chart up here, b, this question, I would say it looks most like this. So we're going to use our one-to-one property here. So going back to b, first thing we want to do is get this 3 to the other side. So we divide both sides by 3. So we're left with 2 to the power of x is equal to 14. Now we can see that 14, we cannot get this to have the base of 2, because 2 squared would be 4, 2 to the third power 8, 2 to the fourth power 16. None of these work to get 14 to be 2 raised to some number. So that doesn't work. So now we have to go back and see what else can we do to solve for x here. So looking at some of these things to get our 2, to get that x out of our exponent, is we can take the ln of both sides. Now our ln of 2 is not going to cancel out like it used to, but we can take this x now and move it to the front. So we have x times ln of 2 is equal to ln of 14. Now these two things are being multiplied, x times the ln of 2. So to get that ln of 2 to the other side of our equation, we would just divide both sides by ln of 2. So we have x is equal to ln of 14 divided by ln of 2. And both of these things we can put in our calculator. So we have the ln of 14, which is 2.639057. Next, the ln of 2 is 0.693147, and then we divide both of these. So we would get x is equal to 3.8074. So if we took this for x plugged it back into our equation, we should get this as 42, and 42 is equal to 42. So we can always test our work by plugging what we get for x back in. Alright, number 3. So we need to solve our equation. First thing we want to do is undo everything on one side to combine some of these terms together. So here we can move this 3 to the other side, so we're just going to add 3. So we have 4 times e to the 2x is equal to 5. We also want to move this 4 over, so we can just divide the 4. So e to the power of 2x is equal to 5/4. Now we have this e to the power of 2x, so to get rid of an e to the power of x, we need to take the ln of both sides. So this 2x exponent here comes out front. Ln of e is 1. So this is 2x is equal to ln of 5/4. So we can find the decimal of 5/4 and then just take the ln of that. So 5 divided by 4 is 1.25. So ln of 1.25 would be 0.223143, and this is equal to 2x. And then we just divide both sides by 2. So x is equal to 0.11157. And I believe on WebAssign it'll be specific on how many decimal places it asks you to have your answer in. And on a test or quiz will be specific too on how many decimal places. Alright, so this is it for the notes today. We'll go over the last 2 pages on the video on Wednesday. Also, the notes are due at the end of class, so make sure you get those turned in. And then the WebAssign is going to be due on Friday morning. So make sure you get the notes turned in, and then you can start working on the WebAssign. It's going to be due Friday morning.